We're really close here.
So what?
We're close enough to get ready.
Oh, cool.
So,
Yeah, so probably like 5 minutes of announcements.
Okay.
It's all on you.
Perfect.
Bob Dobson House.
Yep, absolutely.
I was like,
Yeah, no worries.
I can't screw this one up.
Yeah, Dobson with the B. Yeah.
Yeah, all good. Yeah, so we'll get started in a minute, about a minute, 60 seconds. Yeah, nobody tell the weather's bad because people are still showing up.
Yeah. It's all good.
What's your normal turnout in Dallas?
What?
What's your normal turnout in Dallas?
The DFW DevOps group probably has regularly 20, 25, you know. It's not the same people ever, but, you know, it's about that. So. Exit, minimize value. Hey, it says I can't start sharing when somebody else is sharing. So. There we go. Share screen. What if I want to share multiple things?
Are you all good on sharing?
I need to share the whole, I guess that's the desktop. That's the whole desktop.
Yeah.
Okay.
Boom.
There we go.
And I'll get rid of my face.
No.
Perfect. Okay. I think we're ready.
We're ready whenever.
Yep.
You're always watching. Right there. Out of the class. All right, cool. So I'm going to go ahead and get started.
Hello.
All right, excellent. So I'm going to go ahead and get started. Any first timers here? My favorite. Yes, excellent. A group of people. Got it. Cool. So welcome to the Triangle DevOps. Probably the last one, second to last one of the year. We have one more in November, which is Kubernetes on AWS. It's a primer. It's done by Relic Cloud, and they're going to send some techs out to do like a hands-on workshop with Kubernetes and AWS. So definitely sign up for that one. One other announcement, I've already scheduled January for next year. We will go dead from November through December into January. Not sure the January event, but I have one of my close friends who will be doing a talk on productionizing scripts, so Node, Bash, that kind of stuff, the things to look out for, how to monitor those scripts, how to alert on them, events, things like that. So that should be a pretty fun talk for January. Still working with Red Hat on the Ansible workshop. Went back and forth on the date a little bit. Got a little nervous of saying like mid-November just due to Thanksgiving, people traveling and whatnot. So might push into next year. Oh, it is really raining. Other announcements is anyone? Thank you, of course, to Lifeonic, where there are like Triangle DevOps Life partner for hosting apparently, and Hayes for the food and beverage. And is anyone hiring currently?
Me.
Matt, you
Always
always get to go first.
Always hiring. If you like JavaScript, React, DevOps stuff, as usual.
Hi, I'm Nick. I work for ELIASSEN for this stupid company. Let's just pretend I didn't say that. Anyway, I work for Elastic. If you happen to enjoy JavaScript or JRuby, oddly, or Java, and you want to work on those projects, we have those on our website. So, I work for this service team. also do software for like fire protection and all of that stuff. For DevOps candidate, like most people, they do development.
Excellent. What languages?
Like a cross-functional guy?
Yes.
Wow, that's awesome.
What languages?
Oh, I'm sorry. It's supposed to be we're reading to an AWS. For some easy
Anyone looking? Oh, go for it.
Yeah, I'm Dan. I work for Obvious and work with some people on the customer services side. And solutions architect role. So, supporting our customers all across the country on the deliveries. So what we do, so
Dan will view your LinkedIn profile a decent amount of times. He and I have like LinkedIn viewed each other like 10 times. Yeah.
yeah, so I'm with colleague Bob, who's the state branch Harold Reicher of ELIASSEN. We're not only an Agile consulting services organization, but also at the time that IT staffing technical opportunities to help.
Oh, is everything at some time? And then your eyes are all looking. It's like, all right, anyone looking?
Mark Blackburn, I've been in IT for over 26 years. I've worked in just about every area of IT you can think of. That's why I fit in DevOps. I also do solutioning and solution architecting for entire systems. I'm working on my current AWS Solutions Architect cert. I do not have it yet, but I will have it shortly.
Yes.
Jeffrey Spence. I'm currently working for the agriculture department. So mostly C# and SQL, JavaScript, HTML and stuff. I'm kind of looking, but I'm trying to have to run it to constantly nice. I'm willing to move it.
Okay, cool. Any other announcements from anyone? Do you guys have any exact roles that you're looking for before we move on?
We have a couple DevOps positions available right now. I can go ahead and leave my cards on the table. If you're interested, email me, call me, and I'll be available to talk more about the position. We particularly have a AWS engineer position available, and then a few others we can talk more about. But like I said, I'll go ahead and leave my cards.
Okay, awesome. So if there,
I just remembered one. If anyone has ever written a WC.
cool. And person that just showed up, are you either A, have an announcement, B, looking for a job, C, hiring, or any combination of those? Excellent. So I'm going to go ahead and hand it over to Bob Dobson. Yes. Testing the speed of Agile. And then after he's done, talks about 50 minutes, we'll do a QA session and all that and wrap up. So, cool.
Thanks so much for letting me be here tonight. My name is Bob Dobson. We'll go through a couple of things real quick. Always big on working agreements, right? If you see something, you want to talk about it, we'll stop. This goes about an hour. We can speed up and slow down different parts if there's interest. The thing that might be different here is that at the end of it, we're going to do the best to do like a live demo of how a couple of these ideas work. Okay? Anybody here a developer? All right, be nice to me when you see this, right? The purpose is the testing part of it, okay? What?
That's what I was looking forward to.
Yeah, okay, but just, yeah, we'll do that, but just be gentle, right? All right, so I'm a regional Agile delivery lead for the ELIASSEN group. As Harold mentioned, we are an IT staffing firm that is also has as part of an Agile consulting practice. In that practice, we focus on the full gamut of Agile, from enterprise coaching and business agility on down through team coaching and DevOps coaching. So my role is I get paid to come out and do stuff like this. I'm based in Dallas, but I travel all over the country. My first trip here to North Carolina, looking forward to being back. And you guys all know that the Agile world is divided up into really two kinds of people. People that are developers by background or some technical thing, and people who are project managers, right? Nothing wrong with all those folks. But I'm from the development side of that equation, so that tends to color pretty much everything I say and do. So just be aware of that. A little bit about the ELIASSEN group, founded in 1989 in the Boston area of the Northeast. Two sisters named ELIASSEN, Mona and Lisa. Oddly enough, that was the logo for the company for 15 years, was a Mona Lisa picture or so. We're currently We just bought a company called PSG. You guys may have heard them. They're an IT staffing firm that has a big presence in Raleigh. We're in the process of merging with them. That'll put us at about 350 employees and just a bit over 2,000 consultants nationwide. This doesn't include the PSG offices or our Los Angeles office. So we're around in a bunch of places. This is kind of what we're going to talk about tonight. So we'll talk a little bit about TDD and BDD, and then we'll go through this practical exercise. Do we have any questions before we get started? Awesome. Okay. There is an active participation part of this toward the end. So if you don't want to be part of that, leave before we get to the demo. All right. So I always like to ground things back to the Agile Manifesto, right? Just to make sure we're kind of on track. This is a different representation than what you may have seen before, but it's the 4 values and the principles that we're used to seeing. Just always like to remind people, you know, what the foundation is. I am very much a small A Agilist as opposed to a big A Agilist, but I very much respect the work that the folks did that came up with this. I think it's pretty good, so I always try to go back to it. Tonight we're going to talk about really these principles, mostly, right? Working software is a primary indication of process. The way to convey information is face-to-face conversation and technical excellence. So anybody recognize this? This really isn't the Agile testing pyramid, is it, right? This is really the testing pyramid that most of us see all the time, right? A little bit of automation down here, very small amount of automation, right? And a bunch of other stuff, right? A bunch of manual testing that we do, right? The Agile testing pyramid really looks more like this, right? That's what we want to get to, where there's a lot more automated testing and we have time to actually do exploratory testing, right? The trick is, how do we get to that exploratory testing time, given that we're not going to get a lot more time in our budgets? In fact, people want to shrink budgets, right? Or shrink timelines. How do we do that? The answer is through automation. We'll talk about that tonight. Okay, absolutely. So we'll get into a little bit of that, but I'll just take it briefly here. So a unit test is written by a developer in the same language as the program, and it's written as part of the programming exercise. It tests a single unit in isolation. An integration layer, right? We'll focus on integration test. We'll focus on how multiple components work together across boundaries. Those can often be network boundaries or computer boundaries, right? Certainly system boundaries. User experience layers are things are going to be focused on how does the user experience and what happens when they click different kinds of things, right? Exploratory testings are things like Don will do, which is, you know, hey, how do I just wander through this and see what you didn't think of, right? And this is the thing I think that really drives quality in a product, right? Being able to manually run unit tests over and over again doesn't do a lot for quality, right? Having an experienced, trained, motivated, gotta want a human brain up here doing exploratory testing is where you really get quality from, right? You don't get quality from these, right? You get quality from this. The trick is you have to create time to get this, right? So that's what we're going to talk about tonight. And then UAT testing are the tests that are done by users as part of the acceptance of the thing. The idea is that we go up here, the number of tests gets smaller. We should have a very large number of unit tests, right? Right? And they should run a lot, right? So this is both how many tests and how often they run. We should have a much smaller number of UAT tests that are manual that run a very smaller number of times. Right? Okay. That help that? Awesome. Thanks. And then the speed of the test goes down and increases as you go down this way, right? So these tests are relatively slow, and the unit test should be blazingly fast. Right? And that's a pretty common representation of what the vision of testing in the Agile world is. Right? So this kind of slide talks about why aren't we there, right? Why do we see, right? Why do we see this when we want to see this, right? So what happens, right? We say we're going to do the testing, we're going to do the development, and we're going to do the testing later, right? Has anybody ever been on a project where they said, hey, we got some extra time at the end now, we want to do some more testing? You've been on a project where they actually said that? Okay, good. That's awesome.
Far too many mistakes in the past. And yeah, basically, I feel like we get to this scenario by lack of suffering, lack of making mistakes.
Okay. Most people, I think, have the opposite experiences. When you get to the end here, no one ever says, here's some more time, go do some more testing. I think most people have the opposite experience where we're at the end, we need some time for development, so we're going to take that from testing. right? That seems the experience that most people have, right? The other thing that happens if you try to do it, we're going to do this, waterfall kind of, Scrum and your waterfall and 3-week cycle that a lot of people do, right? You keep doing these manual tests over and over again, right? If you're doing manual tests, they're relatively fragile. People make mistakes, right? And they're also very expensive in terms of time, right? So the whole question is, we know that the exploratory testing is where quality comes from. That's where we find new things that we didn't know, right? So the exploratory testing is where quality really comes from. How do we get more time and more energy to do more exploratory testing? So if we do the testing when we're doing the sprint, right, we're doing the coding, whatever framework you want to use, right, we never find ourselves in that scenario where it's like, okay, we've done all the work. Now we want to see if we did it right. And then if we didn't do it right, we'll go back here, right? We'll have a hardening sprint. And the hardening sprint really means go do it right, right? We did the work, now we're going to go do it right. That's usually what people mean in that, right? So we want to get out of that cycle. What we want to do is make these activities be as overlapping as possible, and again, push hard for automation to create time to do exploratory testing. Right? So again, we talked about unit testing a little bit earlier. This is a definition of unit testing. Some people have other definitions. You guys all familiar with FISTA 5? FISTA 5, is this a good enough definition of unit testing for us to use tonight? Good? All good? Anybody not good? Okay. All right. So again, we want to test the behavior, not the internals, right? We want to be able to change the internal part of the code without having to worry about a test breaking, right? That's an important aspect of it. So in this scenario, right, we made a change to a method and 2 of our unit tests broke, right? So that's an indication that maybe we approached the problem incorrectly, or maybe these tests were bad, right? Could be either or. You got to look at it and see, right? Just having breaking tests isn't necessarily a bad thing. It could be an indicator that we have to refactor something. Certainly, if we make a change, we break a bunch of tests, that should be a code smell for us to go back and say, hey, is this part really designed well? Is there something we can do differently, right? So these are some properties of a good unit test, right? This acronym is as good as any other, I think. I didn't make it up, certainly, right? The things I like about this, right, is that they have to be timely, right? Good unit tests have to be timely. The model, I think, where you say we're going to have a team in some time zone that's going to write code, or we have a team, a different team, another time zone that's going to write tests, I think it's a little bit problematic, right? By that time, you've already lost some cycles on what's the intent of the code, right? So I think timely is a big thing, right? And they have to be fast, right? You guys that are developers, how long are you going to sit around for tests to run? Seconds, right? It takes 10 minutes, you're not going to run them that long or that often, right? You're going to run tests that take 10 minutes. A suite of tests take 10 minutes, you're not going to run that very often. A suite of tests that takes 10 seconds, you'll run that a lot, right? So it's very important for unit tests to be very fast, right? Am I going too fast? Anybody? Good? Okay, all right. So you guys, the developers, hopefully have all heard of test-driven development, also called test-first development, right? This is a practice that I ascribe to me as a developer as having been transformative in how I approach code and the quality of my code, right? It's not an easy practice to learn. It's a different thought process, right? People struggle with it all the time because it does take a lot of work, right? It takes a lot of work to say, how am I going to envision the test for this without having written the code? Most of us that learn, even in college, right, we learn to sit down and envision the algorithm and go write it and think of all the use cases and think of all the switches and ifs and all that other stuff, have a piece of code, and then worry about the tests. Again, that takes us back to that pattern where we don't have enough time to write the test, right? So TDD has helped me in 2 areas. One, it's helped me explain to people how long it actually takes to write good code, right? And that's informed estimates. But mostly, it's given me a safety net for refactoring. Anybody ever walked into a code base and they sat down and said, hey, we want you to make a change in this code base. It's a pretty small change. It shouldn't take you more than a day. And you sit down there and you look at this giant code base and you go, I don't know how to change anything. Anybody ever had that experience or something like that? Okay, anybody had that experience this afternoon? I mean, really, you know, it's really, I mean, it's that much of a common experience for us, right? Right? So imagine you go into a scenario, right? And you're at some place, you sit down there, and they have a culture of good, solid, automated tests, unit tests, right? You sit down there, there's 1,500, you know, 3,500 tests. They've got 90% code coverage, and people feel confident they represent how the software works. And you sit down there, and they say, okay, we want you to make a change in this part of it, right? What are you going to do? Sign me up. There's already 100% code coverage of that part. I'll change that all day long. As long as those lights are green, I'm good, right? So it gives me as a developer, for me, this has been the biggest thing for me. It gave me courage to go make changes to code bases where otherwise I'd say, oh, that's 6 weeks, man. I got to get Timmy on the phone. I got to ask Timmy why he did it that way. Oh, Timmy got fired. I got to go find his Gmail and email Timmy and see what's up with that, right? Before I can ever make a change. So if he remembers, right? Because half the time I'm Timmy, right? I don't remember. I don't remember what I did 6 weeks ago, right? I have no idea why I wrote that way, right? So for me personally, it's that safety net that's been transformative, and that, you know, being able to actually estimate what does it take to write good code, you know. So this is the cycle. We're all probably pretty familiar with this, right? Red, green, refactor, right? The trick here, and this is the hardest part I think for most people that are adopting this, right, is how do we write the smallest code that's going to make that test pass and all the other tests pass. This is the part where I think everybody that starts out with this really gets, you know, stumbles, right? They really stumble with this, right? Because as soon as I write my small test, I'm going to write all the use cases I can imagine in that production code. And if I'm really clever, right, I'm going to write a test that's going to test for all those cases, right? And now I have a big monolithic test, and I have a big monolithic piece of code. You can do TDD that way, but it's not going to get you what you want, right? You're basically changing this complicated problem. We're creating two complicated problems instead of one. So we want to write small tests. And again, be disciplined about writing the least amount of code, no matter how sloppy it is, no matter how inefficient it is, how unelegant it is, no matter what Timmy says in the code review, right? Or what you think he might say. Write the smallest amount of code you can to make that test pass and all the other tests pass, right? And then refactor it when you have that safety net, right? Once you get green, right, and all your tests are green, this is where you're going to go and clean that all up, right? You have another functionality, right? You're going to put it in an if statement to account for something. You're going to start with a test that's going to prove that works, right? People here do that regularly. Not? Is that like a new idea? People are saying, yeah, I hear TDD, but it's like sex in junior high. Everybody says they're doing it, but really nobody is. Okay. I saw that on the YouTube, so they don't blame me. That was a good line. Like everybody laughed at that one. So are people doing this? You guys do this regularly? Okay, everybody close your eyes. Everybody close your eyes. If you're doing TDD regularly, raise your hand. Okay, put your hands down, open your eyes. How many hands got raised, do we think? Who said a third? Yeah, you're way wrong. It was one. Right? So, but again, that's back to my point, right? We think people are doing it, right? And the reason I think, you know, I went through this journey. I think the reason people aren't doing it is this is hard. This requires you to think differently, right? You have to approach the problem differently, and that requires practice and discipline, right?
It's always the nature of your company, your environment. One of my first companies I worked for, defense company, I did this.
You did?
Yeah.
Okay, good.
And
That's awesome.
I have not gone back to a company that has done this, so it's very strange. I was thinking a defense company would be like slow.
Yeah.
But they haven't.
Good. Good. That's great to hear. That's great to hear that in the industry somebody's doing that, right? And that's not been my experience. Every place I've been, you know, and lately I've been brought into places to help people do this, so it's kind of a bad sample, right? Bad random sample, right? But every place I've been, people aren't doing it. Yeah, we could if we had time, but you know, it's easier just for me to bang out the code. We'll write the test later. Or actually, we'll go find some testers to write the test, right?
So what's your impact by not doing this? I know from experience of this one, what's the impact of companies that absolutely refuse to do this?
Well, we see them all the time. Their delivery cycles slow way down, right? The more code you do, the slower it is to deliver. The more code that you write, now we have these extended QA cycles, right? We have this, the code's done, but we have to go put it through QA testing for 6 weeks, right? We made a, what? Yeah, 16, yeah. These are absolutely the stories that we do, right? This is the cost is, we did the work, we just can't realize any value from it for months.
The thing I detected is they actually released code and it's bugged.
Right. So you may be increasing your QA cycles and the quality's going down.
Yeah,
All of it.
exactly. Yeah, and that's, thank you. That's exactly right. You get the worst of all worlds, right? We have poor quality code, and it takes longer for us to get it, right? A poor quality solution, and it takes longer for us to get it. We drive down value, right, in every direction. So, and that's part of the conversation we had. The question I thought you were going to ask, and your name is Stephen. The question I thought you were going to ask, I hope you would, is how do you convince an organization? How do you convince your leaders to do this, right? No, you just do it. Hey,
I'll call it. We actually implemented this, went down the path of XP, and the one takeaway out of that exercise was automating. However, we had a development partner group that had been trained in legacy waterfall and absolutely would not budge. And their thought process was, it's an add-on. It's extra work.
right.
Rather than doing test-driven, it was just, oh, now we have to write automated unit tests in addition to our regular unit test plan. And so there was no value add. So
What were they spending on fixing bugs?
you don't want to know.
No, but that ends up being the argument. That ends up being the argument. You can fix the bugs, or you can prevent the bugs, or you can fix them later. Like, how can you tell me that you can't fix the bugs or prevent them now, but you can afford to do them later? Which is the argument that you give to executives when you want to talk about it.
I guess I have a question. Is there a typical throwdown number? I mean, obviously everyone's different, but is there an industry, at least among the practitioners, to say, if we do it this way, we'll typically save X percent on
There's
the
a chart from SEI from like the 1980s, something like that, that talks about the cost of a bug. So the cost of a bug, if you prevent it, is like 0, right? And as you go through the phases of what we typically consider the software development lifecycle, it changes by orders of magnitude.
It goes up here.
The cost of a bug is $10 if you're doing it in coding.
Right.
It's $100 if it's after coding, but you're kind of still early in the testing cycle. It's it's $100, it's $1,000, it's $10,000.
It's the
It
waterfall.
tends to be a little exponential.
Yeah.
The
So-
longer the project
even-
runs, the bigger the bug problem
Right.
gets. And some projects have been entirely collapsed and failed.
Yeah.
I was involved in one of those projects, related project. I wasn't in that project.
Sure.
But
So,
what happened is, I mean, $20 million later, the whole project was scrapped.
Right.
Because it took them 7 years to collapse it.
Yeah. So there's a number that people go around is 60%, right? So you'll save 60% of your cost of development by doing these things. So to put that in a little bit of context, right? It is. It's a huge number. I took my implementing safe training in Boulder, I don't know, last month, right? And I happened to have Dean Leffingwell as the instructor. Good, lucky me. I had Gene Kim, the guy who wrote the Phoenix Project, in class, right? So he was at the other table. I got a chance to talk. A lot of us did, but I got a chance to talk with Gene one-on-one a couple of times, working some small exercises with him. At the end of the thing, Dean gave Gene an hour to talk about things I've learned since I wrote the Phoenix Project, right? And you're going through there, and I'm a technologist. I'm a developer. For me, this is all great, right? But I'm always thinking, right? How do you convince somebody that's not me, right? How do you convince somebody? He throws this slide up, right? And so what Gene does now, he doesn't do a lot of DevOps stuff. He studies DevOps. He writes about DevOps. He talks about what people are doing with it, and he evaluates data around it. That's what his company does, right? They do very little consulting anymore, right? But they had this chart up there. He said, companies that are doing these things, and he included the whole DevOps pipeline, right? But this is a big part of it. You can't really do DevOps without this stuff, right? You can't have this continuous deployment kind of world if at the end of the day you've got somebody who says they're a tester with a Microsoft Word document and a pencil going, check. You can't do that, right? So this is a big part of this, right? And Gene's got a slide, and he says that companies that are doing these things, these pipeline kind of things, are twice as likely to meet their revenue and profit goals every year. So talk to your CFO about that, right? You're twice as likely to meet your revenue and profit goals every year if we do these kinds of things. So is our development 20% faster? Is it 80%? Who cares? We're twice as likely to meet our revenue and profit goals. The other part of the slide, the other half of the slide was companies that are doing this have increased, on average, their valuation by 50% over 3 years compared to their competitors in their industry. So sit down with your CFO and say, hey, would you like to increase our valuation 50% compared to our competitors? Now, is it a cause and effect relationship? Maybe, maybe not. Maybe companies that do these things have other things going on, right, that are making it happen, right? Making all those things, great things happen, but it's pretty compelling, right?
Is this a public deck that he delivers?
Yeah, you can go find it. Yeah, you can go find it. You pop me an email and I'll send you the link, whatever it's absolutely out there. Yeah. So this is like a common scenario that we see, right? And we've talked about this a little bit, right? So we've got, and I didn't put the pointy ears up here, but you know this guy, right? The pointy hair up there, right? So we got some project, right? And all he wants to know is what's the status. Project manager says, good. Started the project. It's awesome. We got a great team. We can do this, right? What does the architect say? Oh, this is a great way to use this new technology, right? It's an awesome technology. It's going to save the world. We're going to save so much time by using this technology. The developer says, hey, this is just like some project I worked on before. I can just copy and paste this code. What does the tester say, Don? Right? That's what the tester says, right? So what happens in the middle of the project, right? Same question. Project manager, oh, we're doing great. Things are going fantastic. Couple of problems, but I can take care of them. I can get the team organized. I'm that person. I can drive them to get that done, right? Architect's like, oh, that didn't look anything like that other architecture. I got to go change it out. And the developer's like, man, that code is completely different. It's not going to work at all. I got to start from scratch. And I just wasted, 6 weeks or whatever, right? Tester, same question, right? Tester always asks the same question. How many minutes do I get to test before we release, right? At the end of the project, what do we say, right? The architect's working 90 hours trying to catch up. Anybody been an architect? Worked 90 hours trying to catch up on something, right? Yeah, we've all done that, right? And the tester says it does everything except work. It's all awesome. We've got all these great status reports for months, right? This product is great. It does everything except work, right? What happens next? Right? You guys all call Harold and say, you got any openings? Right? And we've all experienced this. We laugh because everybody's had some encounter except the gentleman over there who's gets more time to test. He's probably, I don't know, that's a rarity to get more time to test stuff.
The story of this is there's a version of Elasticsearch that we released. Okay, there are a lot of stories, but one of the stories, we released a version of Elasticsearch that people very quickly contacted us and said, hey, this version, when I update a document, now I have 2 copies of that. And then within maybe, we figured out that the problem is that we accidentally changed the hashing algorithm that we use to distribute the document system. So no wonder there are duplicates. And so we discovered a whole class of tests that we had never run. This was 3 years ago. And so we had it we fixed the problem and immediately released the next one. But then between that release and the next minor release, everyone spent tons of time adding more tests of this class and growing on tests of the class where you have the distributed system talking to itself and testing these things. So yeah, stood up. And this is why I say that the way that you get to do this is by embarrassing yourself.
Yep, absolutely.
Is by making a big mistake. So that version of Elasticsearch is not available on our website. That version is dead.
Right.
It's available on Maven Central. You can count some things out. Stop.
Right.
But that version is forbidden.
Right.
Because it's so broken.
Yeah.
And because we've had this class of bugs. Never again.
That's that curve that Don was talking about, right? Very expensive to find those when they're in Maven.
Well, you can't, they're impossible. Anyone that has that particular version of Elasticsearch just has to.
Yeah,
they have
absolutely.
to. So
Yeah.
we can cause a lot of people a problem.
Absolutely.
Yeah. Now we have so many tests that test for this particular kind of thing and all the other things that are like.
Good. Right?
Stuff to work.
So kind of the takeaway from here, right? The primary measure that we care about needs to be working software, right? The project manager asking this question or sending a status email, right? Anybody ever here been CC'd on a status email and you go, it's not exactly right, you know, it's not exactly the status of the project, right? But these, you know, all these different ways really don't measure how things are going, right? So, you know, what's a different way to look at it, right? So we go back and we say, this is the principle we care about, right? We'll talk a little bit here, but you know, I don't want to make this really a tooling discussion. We can, you know, another session on that, right? But in terms of ideas, right? What if we change the dynamic so that instead of talking about emails and status reports and saying how many hours we've burned down and all this other stuff, right? What if we said how many of our tests are passing versus failing, right? And what if, you know, if you're using story points, if you're a team that uses story points, if these are story points, right? It's even more meaningful, right? How many points do we have passing versus failing or not run, right?
At first glance, that was horrible.
It does at the end of a first sprint, right? Yeah, it's horrible at the end of a sprint. But again, this is an entire backlog, right? This isn't the work from a sprint. We probably wouldn't take 698 points into any sprint. I know a team that could have done that, but they had a lot of 182-point stories. Anyway, so they, you know, at the end of sprint one, right? They would, you know, this is what we look like though. Good, bad, or indifferent, I don't know, but this is really what it is, right? This is what's working, right? You just go on and these numbers change, right? And you get down here, you know, is that a big problem? I don't know, you know. Maybe we don't need that. Maybe that's something that, you know, we kept prioritizing this thing, we kept going down and we don't care. And maybe we just don't care about that, but at least we know what it is, right? We know that thing's not working, right? Do we ship it? I don't know. You know, just maybe it's not in there. Maybe that code's not in there because we haven't written the stories yet, right? But the idea here is we want to move from this, you know, get everybody on the phone. How's it going? Are you guys on track? That doesn't help anybody, right? We want to get to something that's more like this, right? So how do we do that, right? So let's talk a little bit about behavior-driven. Anybody got questions on TDD or anything so far? Okay. So let's talk about behavior-driven development, right? This is from Dan North's site. And he acknowledges down here that it's kind of growing, right? This idea of BDD is growing. So probably throw a rock in the room and get, you know, 4 or 5 different perfect definitions of what BDD is, right? So I'm just going to say, you know, for purposes of tonight's conversation, right, it's a way to test components of software together and not worry about how they're structured internally, right? And I'm going to say it's done in an automated way. I'm going to say that if you're not automated, you're really not doing behavior-driven development, right? If you write a feature, you know, in Word and you print it out and you put it on your desk, I'm saying that's not BDD, right? That's interesting, but it's not BDD, right? So how does this work? This comes from the Cucumber site, right? And a lot of people I meet all the people all the time saying, we don't need to do TDD because we do BDD. Like, okay, to me, that's like saying, I don't need to brake because I accelerate. You know, I don't need to steer right because I steer left, right? You know, if you're a NASCAR guy, maybe that works, I don't know. But for me, you know, I got to do a bunch of things, right? I think in order for me to drive a car, I have to do a bunch of things all at once, some of which relate to the accelerator, right? And I have to do TDD and BDD, both of which relate to testing, right? I think they're done by different people. I think they're done sometimes using different skill sets. I think they have different purposes. And I think they produce things that run on different intervals and at different times.
I'm doing a lot more of this, where they give me a feature and they tell me to come up with behaviors or the use cases of the feature.
Mm-hmm.
So I basically put placeholders for different UIDs or IDs, ideal behavior testing with Protractor, and I just put, I know what the steps should be, because we have in the stories, we have information.
Yeah.
So I can create most of these type of tests before the even developer even starts code. Even like if they're developing the architecture, I sometimes ask them, okay, just give me some of the ideas you might use for these different things. So I've been doing a lot more of this first.
So what happens at the end of a cycle, whatever you call it, sprint, whatever, you've had this conversation, you've taken these bits of information you've gathered from the team, you've proactively gone out and done those, and you write a test, and you say, hey, here's the test we're going to run. What happens to the number of times you get to the end and the developer goes, man, if you would have known it, I would have coded it that way. If I'd have known that's what you wanted, I would have coded that way. Yeah, they go down, right? Anybody else ever, as a developer, you've ever gone to demo something, you know, and somebody goes, oh man, I wish it would have done X. And you go, yeah, if you told me that an hour and a half ago, it would have done X, right? So, Stephen, those are great behaviors, right? You guys are doing the right things, right? To the degree that we do that, right? And this is not exploratory testing, right? The whole purpose of this is to get more time to do exploratory testing, right? This is known testing. We know what our system ought to do, right? We know that when we add 2 and 3, we should get 5, right? These are all things that we know. These are not exploratory testing, right? The idea here is to do this stuff up front to prevent the bugs from getting out there, right? Whether they're bugs in code or bugs in understanding, right? Defects in understanding, right? Prevent those from getting into the code base in the first base so that we have more time to do more valuable testing, right? So that's the whole goal of all this, right? So how do these work together, right? And this is where a lot of people get confused on too, so we'll try to go through it, right? So we got a developer down here using TDD, Test-Driven Development Writing Unit Test, right? And the developer, she's going to start writing code here, right? And she's going to start in this order class, and she writes a test, and it fails, and she writes a piece of code, and the test passes, right? And she keeps doing that, right? She's writing code, right? So this is in isolation, kind of, right? There's not much here, right? So Stephen, right? Stephen's part of this team, right? So he's gone in here now, and he started writing these behavior tests, right? And he's working maybe with a tester, maybe with a business person, maybe with another developer, who knows, right? There's some couple of people here that are working writing these behavior tests, right? And they're red because we don't have much of the system done yet, right? So now we keep writing, and our developer down here, she starts cranking again, right? She's going to start on the next part of the system, right? And she's doing the same thing, red-green refactor, right? She just does this red-green refactor, right? And as that starts happening, these tests start turning green as we run them, and they pass, right? We just repeat that process. As the system becomes more complex, has more pieces, we can see that evolve by the passing tests, right? But the presupposition here is that you got somebody like Stephen around who's writing these tests ahead, right? That's what has to happen. This won't work if you say, well, we got this big pile of code and functionality and components, now let's go write some tests, right? That system will almost always break down until we don't have enough time to test. So it's critical to have the stuff in place, but mostly the mentality, right? To say, let's write these tests up front and do that in a way that we can automate them.
How do you feel about the deployment of groups where these are not separate? Where sometimes there's only one person, so maybe they're basically where the skill sets are.
Yeah, so I don't understand that question completely. Let me repeat it back to you. Okay. Your concern is that it's a small group, maybe just one person, who's developing a moderately complex system. How does one person do that?
No, it's
not
one
okay.
person. It is more like some teams opt to have one person do it sometimes, and this is a disaster in your experience.
No, it can be, but in my experience, it's not. So I'll go back to the Agile Manifesto, right? The best architectures, requirements, and designs come from self-organizing teams. How that team breaks up its work, that's up to that team. Now, as a coach, right, if I see something going on, if I see one person do it, I'm going to say, what happens if Timmy leaves, right? Who's going to write that test if Timmy leaves? Maybe we should start having other people pair with Timmy or do something, because if Timmy's the only person that can do this and Timmy leaves, right, then who's going to do that? That's a risk, right? So as a systems guy, right, I'll look at that and go, the system we want to talk about, but I will defer to the team on how they want to organize their work because I believe in that, right? But I will absolutely coach them from my experience to say, dude, if Timmy gets hurt or he's gone, how do you guys do that, right? And most of the time as they start to see that, they'll go, oh, so give us some coaching on how to do that. Pair, go sit down with Timmy, take Timmy out, buy him a beer and say, Timmy, tell me all your secrets, right? So, right? So then we just keep going, right? This cycle just repeats as the system gets more and more complex until all the tests are green and the guy with no pointy hair up here but really should have pointy hair, he's happy, right? He doesn't know any of this stuff. Back to your where you thought you were going.
I wanted to build on what you said. In a lot of systems, it's technically like no one's really called a test engineer or quality engineer. Every sprint, something just changed, and or even during that sprint, you automate one story, someone else develops that story. You're the automating tester. You break the story. The test for that story. Someone else is the developer for the story. So you just keep on changing places.
Yeah.
It's worked great in one of the companies I worked for. Even one company I worked for had 3 different organizations. The organization that worked like this did so much better work, quality work, versus the other ones that just said, no, we're not going to do that. So even within a company, so that's kind of what I'm trying to do now in the company I work for now.
Okay.
So like when you said, oh, I should be able to change organization, it will take time.
Yeah, it will. Yeah.
I just got here. So.
No, it absolutely does. These are not trivial changes. I don't want to have anybody be under any illusion. All this to get people to do this stuff, this is hard work, right? It involves having courage to sit down here and say, follow me, I'll do a little bit of it, right? I cheat, right? I'm a coach. They bring me in to do that. So sometimes they listen to me just intuitively because I'm there, right? But if you're the change agent inside, right? This is hard work. You got to sit down and get people to trust you, but you got to take a risk. You got to be able to do what I'm going to do tonight, right? Something's going to go wrong with my demo tonight, guarantee it, right? But we're not going to get better unless we do those things. Right? No organization is going to get better unless we kind of stretch and fail a little bit, right? So, So the whole idea is to get this guy happy, right? Now, the beautiful part of this is once we get here, right, and the system's done, right? Now what happens, going back to our pyramid, right? Think about our pyramid, right? Now the green level's up here, right? Now as we go to make changes to the system, we can ensure that it's still healthy all the way. And because we did TDD and BDD and we have automation in place, right? We can do this at the fraction of the cost. These guys aren't writing these tests again, right? They wrote them once and now they just run over and over and over again, right? So now these guys have taken their brains and turned them to exploratory testing, turned them to the new features, right? Turn them into, you know what I'm going to do? I'm going to go out and buy a beer for one of our users and just kind of have them use the app in front of me and see what happens. The time to do that comes from breaking this cycle through automation. That's the only place the time comes to do that, right? Right? And then, see, I keep going back to this point, keep getting pulled off, right? The question is, Bob, how do we get this guy to give us permission to do this stuff, right? So if you're a developer, it takes no permission to do TDD. Because really nobody knows.
Boss is looking at the commits and saying, why are you doing that?
Well,
I've seen that happen.
So that's a rarity, right? But that's the exception, I think, right? And now we go have that conversation with them, right? But most of the bosses I've worked with don't know, don't care, right? They have no idea. There might be an architect that's looking at commits, but I've never had like a manager look at a commit ever. So maybe I work in some odd places, right? But I've never had a manager look at commits. So if you're in that scenario, you got to have some conversation. Well, that's a different place, right? Yeah. But but if you're not in one of those places, right? If your manager says, how long is it going to take? And you say it's going to take 8 hours. He goes, okay. And he's done in 8 hours. Then you just go do this. You just start practicing, right? And you figure out how long it's going to take. And now over time, this becomes your estimate. It includes this. How long does it take to write code, right? The implied question there is, how long does it take to write good quality maintainable code that you're proud of? right? That's the implied question. It's not, the question isn't, how long does it take to write the smallest, crappiest code that you can get to hand off to the QA guys? That's not what that question is. It's never that, right? It may sound like that. Like they may stand in there with a, you know, a project schedule beating you over the head. It sounds like they're asking that question, but they never really are, right? We should never answer, you know, that question, how long does it take to write crappy code, right? We should always answer, how long does it take to write good quality code? And we're developers, we have that in our ability to do, right? So Gherkin, anybody heard of Gherkin? Right? Gherkin is quickly becoming the lingua franca of automated testing, right? It's what people use to do a lot of BDD and ATDD and other kinds of DDD kinds of things, right? So this is the syntax that we see in Gherkin. There's this high-level concept called a feature. In most cases, this is stored in a file of some kind, right? And in it, there are a number of scenarios, right? And scenarios have this kind of logical thing. And all this is written like in business language, right? This is all written in business language. There's no class names in here. There's no method names, no interface names, no technology names in here at all, right? It's all written in business language, usually, hopefully, written by the business people, right? Hopefully, you're not in a kind of environment where you have, you know, the business people come in and they throw you a PowerPoint, and somebody's got to take a PowerPoint and turn it into something else, right? Microsoft, 4 or 5 years ago, started a cycle. They laid off 4,500 testers. It was like, hey, wait a minute. What's going to happen to our code quality if you lay off 4,500 testers? They said, well, what we're really doing is we're going to have all these testers really do when we sit and look at their work is they just take the requirements from the business people and enter them in the tool, right? So now we're going to tell the business people they have to enter them directly in the tool, right? And so these 4,500 people, you can some of you can become business people, right? And help us with the business part of it. With this job of, I listen to a business person and I just put it in a tool for them, that's kind of going away, right? We want to bring the business people closer to what we do, right? Now, as IT people, we're going to have a different perspective. We're going to see things. We read blogs. We go to conferences. We do all these things, so we probably have a different view of how to do testing, right, than a business person, right? We want to bring them along on that journey, right? So again, a scenario given, you know, and there might be a couple game conditions, given, when, then, right? And the idea here is to create something that's going to have values in it we can test against, right? And that's what gives us that red-green magic that we love, right? So this is kind of what one might look like, right? This is a different version of one. The kind of, this is generic, right? But we've got some values in here. And the idea here is that in some instances of some implementations of tools that use Gherkin as a driver, right? You can put a table in there, right? So now imagine you're going to go test something and they say, we've got all these different conditions. Anybody here in healthcare? Plans, right? Plans have expiration dates and start dates and end dates. And they can be very complicated, right? So for the guys to say, oh, we can't go fast because this is complicated, it's like, dude, if, you know, this is today and that's tomorrow, that has to be a year from now, right? That's the rule, right? You can just make 1 million of these, test them at the speed of light, right? Okay, we can do that. Again, not all implementations of Gherkin have that, but some do. So as you're shopping, that becomes a distinguishing point. You don't do tables, we don't want to talk to you. All right, so SpecFlow is a framework that works in the .NET world to interpret Gherkin files. That's what we're going to use in the demo tonight, right? So SpecFlow is just a plugin, right, for Visual Studio. It can just consume Gherkin files, and it actually can consume Gherkin files, turn those into structures of classes, and then it can run those and put the results back in Test Explorer. Anybody .NET folks here? Okay, so the .NET folks, you guys all Java folks or other folks? Java? Ruby, okay. I don't know Ruby too well, so I don't know how.
Cucumber.
Yeah.
Just look at Cucumber.
Yeah, okay.
Cucumber and SpecFlow are almost the same.
Okay, awesome. So, with the demo that we'll see tonight, we'll start that in just a minute here. We'll be in Visual Studio, right? For you Java guys, think, you know, JUnit, right? And think Mach, or I think Makito or whatever you guys use, whatever, right? But the concepts are all the same. I'll cover those as we get in here, right? .NET guys will kind of see what we're talking about, right? Anybody got any questions on TDD, BDD so far? Okay, yeah. Oh, we're out of time. Sorry, no. All right, so we're going to go ahead and jump in here then. So let's talk about how this really works, right? So here's a development team. I'm a big fan of self-organizing teams. Big fan of them, right? I coach people to do that all the time. The teams that I'm on, I'm not on a development team right now, but I'm working really hard to get my boss to say we have to be a self-organizing team too. You can't be handing out tasks like that, right? So on this development team right here, we got a couple different people with different roles and different experiences, right? And how does this really work? So this feature file, right, that's get written in this Gherkin language, right? Typically, anybody on the team can do it, right? But typically, it's like a business guy and a tester, right? Kind of working together on it, right? That's typically what happens. Maybe the business guy writes it, maybe the tester writes it, and the business guy edits it, maybe they sit down together or something like that, right? But that's typically how that is done, right? And the reason for that is the business person knows the domain. They know what the business result ought to be, right? And the tester, again, have these awesome brains to kind of think, what about this? What does this mean? What about this? Developers will do that too, but testers, people that have, self-identified that way, seem to just be better at that. They just like it, right? And then when we go to write the test code, right, that's often done by a developer, right? She'll do that, right? And then we'll have a tester maybe working with them. We see more and more testers becoming coders, right? Because they're writing these kinds of things, right? We used to say we want our testers to be able to write fully formed, functional, grammatically correct paragraphs, right? Because they're going to go in a big Word document. Going to go down there, right? You guys, Indiana Jones and Here's the Lost Ark, right? All spec documents go into that warehouse. You know that, right? All spec documents ever written in the history of IT go into that warehouse where they put the Ark at the end of the movie, right? Nobody can find it. Exactly, right? So now we're saying we don't want testers to write paragraphs anymore, right? We want testers to write Gherkin files, and maybe we want testers to write code too, right? So the world is kind of changing, right? And that puts stress on people, right? So you've got to be aware of that. But it really is because, again, at some point, every CFO is going to say, I want to be twice as likely to meet my profitability. And I saw Gene Kim's slide deck, and Gene Kim says if we go do this, then it'll happen. Not that simple, right? But some CFO is going to say that. These changes are coming, so get ahead of them, right? Okay. So if you're a .NET person, right, you'll kind of recognize this. It's hard to see a little bit, right? We've got two solutions here. If you're a Java person, I don't know. I guess it's a project is kind of your same thing. And no, it's not. What's the level above a project in Eclipse? Java guys, anybody?
Working set.
Yeah. Yeah, it might be more like a working set. Yeah, it might be more like a working set, right? So these are two different solutions in Visual Studio, right? And both of them contain the production code, right? A reference to the production code. And sometimes, that reference will really be a DLL, right? But that's a bad practice in my opinion. The reason is because we're going to add delays to it, right? If I'm a and .NET guys, right? If this is a reference to a DLL, and this is if this is the reference to the DLL, and this is my SpecFlow project, right? I got a cycle. I have to go build that DLL and distribute it in order to test it. Maybe I don't want to do that, right? Maybe I want to have an environment that's a lot more interactive where I can pull down your shelf set and do that right now. So this is probably a better way to do it than the DLL. Okay. And the other one is has a unit test, a test project with unit tests in it, right? The other solution does, right? Okay. All right. So this is my non-trivial solution that I have here, my non-trivial business problem. And the thing that makes it non-trivial for the non-developers in the room, right, is this thing right here, right? This thing right here. This non-trivial system, right, is going to communicate with some external entity that we don't know much about. We know it has an API. We can read the spec on it, but we don't have one of these yet. We're not going to have one on site for 3 months because the procurement guys aren't agile and it's going to take them forever to write a PO, right? So we want to start coding now, so we make an interface, right? By making this interface, right, we can make this interface behave as if it's the API, right? And we can read the documentation on the API. We can go maybe if it's open source, we can read the code, we can read their tests, we can find out what it does. We make this interface to behave like it. That's going to allow us to take it out and create our own mock so we can go forward, right? So it's this item right here that makes it non-trivial from an architecture point of view. Okay? All right. Questions before I jump in here? No. We just want to see your code. We want to see your burnout, Bob. All right. So we're going to jump down here. And looking for my menus here. Oh yeah, we got to do, this is the interactive part. All right, so we're going to kind of go through this, and it's important. I don't have a helper here, right? So, but what I do have, I want to wear different hats, right? So this is my tester hat, kind of an Indiana Jones thing, right? Working, right? Okay, so this one is the Indiana Jones theme. Who can do the Indiana Jones theme? Dun-dun-dun. Okay, you guys. All right. So that's my tester hat. Which hat is this? So my developer hat, right? Right. Okay. All right. So I'm going to try to wear the hats so that you guys are kind of clear about who's doing what, right? Okay. So we'll see how well this works out. All right. So let me start with this one here. Okay, so this is my project that has unit tests in it, right? For those of you who don't know, this is Visual Studio. This is called the Solution Explorer. I've got a couple projects in here, right? This is my product production code, right? And then this is my unit test down here, right? What I do, this is a convention that I do, Bob does, right? I always put my test on the left-hand side and the code they're testing on the right-hand side. And I do that because I want to remind myself that the tests are first-class citizens, right? I do that. That's a conscientious affectation I do to make the test first and foremost in my mind, right? So that's, you know, maybe some other people do that too, but I learned for me, if I do that, it really draws my eye to it, makes a difference, right? But I can always see the code that I'm testing right over here, right? So let's see here. So I ran these just before we started, just to save a little bit of time. And the idea here is that this is a project that's in mid-flight, right? So I didn't want to, in the interest of time, I didn't want to build it from the ground up, but we'll talk through it. So again, this is the Test Explorer in my unit test project, right? I've got 10 tests and they're all green, right? So now I could go add functionality to this if I wanted to. Okay? So that's this one, right? This is the cowboy one, right? This is the developer one, right? So I'm going to change hats, right? You guys got to do the sound effects, man. It was so much cooler in my head when you were doing the sound effects. All right. So this is my other solution, right? And again, this is done in Visual Studio. There are many different platforms, many different ways to accomplish this. So don't get wrapped around. You mean the business people have to learn Visual Studio? No, it's not that at all. Just for this purpose, for this demo, this is what I'm showing, okay? A lot of times these feature files are written in tools that are put on websites. In the case of Visual Studio, you're using TFS. You can actually go in and edit the feature files right in the browser, right? So somebody sets this up. They create the file, add it to the solution. Anybody can do that. You tell the business person, you don't have to go into Visual Studio. You can just maintain the feature files right there from the website. So that's absolutely a way to do this, right? So this is a feature file over here, right? It's got a very simple given and, when, then, and kind of thing in here, right? Pretty simple kind of thing. So let's kind of look at this a little bit. This piece of code right here is kind of the glue that SpecFlow creates and then SpecFlow uses to connect the feature file over here with the production code, right? And again, in this case, the production code is up here, right? So this is the same production code we have, right? So this is the structure of it. This is this given, right? So this is a given syntax. So this method, right? If you're not a developer, this is a method. This method runs at the start of the scenario, right? Given, it's going to go set a bunch of stuff up. You can think of it as a setup, right? And then down here, right, when something happens, right, and right now we've got that pending because we haven't done that part yet, and this one's pending too, right? So we're going to run this test, right?
Real magic. Basically, stuff that the test does. The cool thing here is that you can then take the same thing in English and modify ever so slightly English, and most of the same references will still do the job. And they'll still work.
Right.
Well,
Right.
I think this is really cool, and I love also the thing about
Right.
you don't have to know how to do it.
Right.
So the other thing that's similar to the first thing you said is separation of the what versus the how. So if you're talking only about what the behaviors of the application are up in the scenario, it doesn't matter how it's actually implemented. So you could say something in your scenario like, you know, when the user deletes whatever. And maybe there's a delete button or a delete link or a Command D shortcut or whatever. Who cares? But what it does is it tells you about the behavior, and then if the underlying implementation changes, the test doesn't have to change at all.
Right.
It's the code that goes in between that's going to need to change to work on the underlying computation.
Those are both great points. There's another great point too. We'll see that in the demo, right? So, okay, so now we got this pending, right? So what does this look like, right? So now going back, if you remember, I had that thing where we say, you know, we want red, green, how many of our tests, whatever, right? We don't necessarily want things to fail unless they're broken, but we want to have this pending kind of concept, right? So we're going to go run this, right? This is our test explorer. It runs eventually. Right, and so it says pending, right? So you get the little thing here, it's yellow, not red, not green, right? Pending, right? Okay, so now we've got this scenario that's not done yet. Right? It's not failing, but it's not done yet. And again, just imagine we've got 1,200 of these, right? What does that look like in terms of a system, right? So now we're going to go back to over here, right? So now we're going to go back here, and we're going to go back to our unit test, right? So now, in my unit test, now they say, okay, we got this thing, we want to do something with the game display, and we want to kind of, you know, control how it gets displayed on the screen, right? So I'm going to go, and I'm just going to start, and the first thing I'm going to do here is I'm going to add a test class, right? So, add unit test. And it adds my test down there, and I'm going to rename it real quick. And I had a conversation with the architect or somebody, so I know I'm working on a thing called the game display class. I don't stress about that. I just go have the conversation, right? Game display tests, right? And now I'm gonna use a tool that's built into Visual Studio for purposes of the demo. You obviously can't write a lot of code this way, but I get tired of having people watch me make typos, right? So this is called a snippet, right? So I'm just going to go here. I'm going to control. Okay, I got all my snippets set up, right? So I'm going to go snippet for this demo, and I've got one, right? This is my first thing. So all I did was put a using statement here to say, connect me to my production code and connect me to the mock framework, right? Because I might wind up using mocks because I've got to do this thing, right? So I'm going to go rewrite this test, right? And again, I'm just going to use a snippet because I don't want to type it all. Snippet. But I did that wrong. Did it? Yeah, I did it wrong. Control Z. It's just this part. No, it's just this part. Every time, something different. All right. So now I have a test in here, right? And a test is really just a method in this class, right? And the first thing to notice here is I got my red squiggle line. So going back, we're doing TDD now, right? Red, green, refactor, right? Failure to compile is a broken test, is a red test, right? So we now have our red test. So I'm going to go write the minimum amount of code to make that test pass. And that's just going to be a class that has that name, right? So I'm going to go do that. So I'm going to add a class. I'll call it game display. I'll pull it over here because I'm just kind of that way. I'll make it public, right? Okay. So now I go down here, and that will come up, and those will change here. And then we'll see, we got a couple other ones, right? So this is a method I don't have. So my tool is going to help me correct that. So I'm going to generate a piece of code for that, right? Again, that's the least amount of code I can write to make that red go green, right? Right? And if you notice here, if you're a developer, you notice this is going to throw a not implement exception, right? So this code would actually fail to run. This test would fail, right? Which is okay. That's our red test, right? What I'm going to do here, right, is I just want to kind of replace all this code real quick, just in the interest of time. Control KX, snippet, and we'll talk through it here once I get it done, right? Okay. So now I went and added code, right, that's kind of fleshed out some of this, and really I don't have any red on any side here, right? So now I've got a test that's complete. There's no failure compile in my test, and I got a piece of code over here that doesn't work. And I know it doesn't work because when I run my tests, right, it's going to fail over here, and we're going to have a red test. Right, so I have a red test. Good, I've got a red test. So imagine the scenario now where I've got 1,200 tests that run in the same amount of time. I just added a small piece of code. I added a class, right? But I know everything's okay. Everything's okay. I'm comfortable with that, right? So now I'm going to write the least amount of code over here. It's going to make this test pass. Right? So I had the least amount of code I could to make it pass, make the test pass, right? Okay. So that's that cycle. That's that red-green refactor cycle, right? And the important thing to note there is I'm really writing relatively small tests. This test would get refactored over time as I pulled the mock out and the setups and all that kind of stuff. That test, if it went through and you looked at some of the tests, you know, there's 2 or 3 lines of code. They're very small tests on purpose because the small test breaks, I know what happened. Right? If a big test breaks and tests 8 or 9 things, I don't know what happened. Right? But if a small test breaks, I know exactly what happened. Right? So it's kind of critical there. Right? You ready? Another hat here. Music. Cue the music. All right. All right. Good. 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 All right. So now I'm going to go back over here. Put on my tester hat. Right. And it just says I did some stuff there. All right. So now I'm going to go back here, and I'm just going to add some more code to my my regex processor. Right. So I'm going to do control. Right, so that's just, there's a reference to that, right? I'm gonna go down here, I'm gonna update my when, right? So it's given when. So I'm gonna add some code here because we have a class now that we didn't have before. Remember back the one with all the different colors and all their stuff, right? I'm now playing the developer, right? So now I'm gonna go, we have more code now, so I can update this. And again, this could be done by a tester who's coding, or maybe a great business person, right? Maybe not. Or it could be done by a developer. Self-organizing team. 2, right? And then I'm going to go down here and add just a test. Again, this is my then method that's going to prove what happens, right? Okay. And now I'm going to go run my test again. Again, this is my BDD test. This would run as part of, you know, an automated build or something like that, right? And it's green. Awesome, right? So we've got a behavior. So is that the end of the story? Anybody here from Kansas? Anybody here from Kansas? Okay. Kansas is famous for cow towns, right? Abilene, Dodge City, right? What happens when the Cowboys get liquored up? Who knows what happens, right? So what happened in our house, right, was somebody, maybe on the team, maybe not on the team, came to the developer and said, hey, you know, I got a great idea. We need to change how we display the player's name. Can you help me with that? Like, oh, yeah. I know where the code is. I can do TDD. I can help you with that, right? So the developer jumps in here, right, and starts rewriting and says, oh, I'll rewrite this test because we're changing that. So I'm going to rewrite the test. I can do that real easy, right? Right, I'm going to rewrite that, and my test is going to fail, right? So I just changed the test, right? So that's going to fail. That's good though. I'm the developer. I go, that's great, right? That failed, awesome, right? So now I'm going to go back and I'm going to make this work, right? I'll run this and it'll pass. Oops, I did that wrong. It'll fail. Yeah, if you have code that's kind of repetitive, like if you want to set up like your test, you want your test in a certain way. You know, hey, I'm testing this part of my code. always have to set up these mocks the same way. You can use them for that. You can use them for all kinds of stuff. Some people, I worked on a project where we had a lot of repetitive services. We made snippets for them so the guys in India could do it right. So, and the snippets are pretty powerful. You can actually put substitutions in there, right? So you can say, you get a little, in the interface, it will say what's the real name you want to use and stuff like that. Really very powerful technology. So now this will pass, right? So we're happy, right? So we can go ship this because, you know, we got a new thing, right? But back to the case with the hash, right? Really, what's going to happen when we go to do this in our BDD world, right? All right. So what happens now, right? All right, and now our test failed, right? So the developer got crazy and did some change, but our test failed overall, so now we're safe. We're not going to ship that code. Thank you. We're not going to ship that code because we changed a business rule. Somebody changed the effect of a business rule without us having a conversation about it, right? So now in your team, you can say, okay, who can control that feature file? You know, how do we see that? What are the working agreements around when we change a feature file, right? And so that gives you that big safety net. So in addition to the things we heard earlier about the benefits of it, it also gets us a safety net where we're not going to, if we can all look at the feature file, you have people looking at the feature file and saying, that can't change unless we have a meeting, right?
So is the concept almost that BDD should be supervisory to TDD?
Yeah, you can say that, right? It tests different things, right? So, but it has that safety net feature to it. Yeah.
So they're testing very different things.
Right.
It's not doing it in the demo because it's a lot of setup.
Right.
But I think it's actually very common.
Yeah, but it's definitely, they're definitely different things. It has that benefit. Again, I'm a big fan of synergy, right? So one of the things I like about all this stuff is you get synergistic. We do this stuff, and suddenly we built the safety net that really wasn't our intent, right? Works out we have this great safety net, but our intent was to just make sure we knew that something worked today. Now we have this great safety net too. So that's kind of the end of the demo. Questions? I'm a little bit over my hour. Okay, so real quick, just to kind of go back through what we talked about, right? TDD and BDD are techniques that teams can use to reduce the amount of time it takes to do testing, and at the same time to prevent bugs from getting into code, which reduces the cost of resolving those bugs, right, exponentially, right? And we can plow that extra human power we got back into not rerunning manual tests or not arguing with each other, right, about what's it supposed to do, right? We don't have to have those arguments anymore. We can go look at the test, right? We take that time and, more importantly, that emotional energy and plow it back into making the product better, right? And that's the goal of all that, is to give us the time that we need and the energy that we need to make great products, right? And deliver value. Questions? Is the 5 useful? No twos. I don't see any twos, so that's good, I guess. So, okay. All right. Appreciate everybody tonight. Do we have any closing statements? Chris, anybody? Okay. All right. Thanks, everybody.
Thank you.
Useful?
Yeah, man. Thank you so much.
I mean, it helps. It was in line with what you thought.
Oh, yeah.
Good.
Yeah.
Good. Okay.
Thanks, Bob.
Yeah, absolutely.
Might be a bit off topic
Sure.
from this, but I have run across it both in my experience and a couple of other people I've talked to. When developing